Before we can approach any type of physics problem, we have to consider what perspective we are viewing the situation from. This is called our frame of reference. In order for us to perceive motion, we need to use something as a comparison. For instance, when someone drives a car, they know they are moving because the trees or landscape are getting closer. Because of our need to use references, our perception of motion can easily be manipulated. Reference frames are a point of view. How we see things can change depending on our position and situation. Most of the time, we consider the Earth to be our frame of reference. Everything that we see is in respect to the motion of the Earth. When we stand still, we can say that we are stationary, but this would be only partially correct. Someone from space would say that we are rotating at 465 meters per second, over 18 times faster than a car. Technically, both answers are correct, but how is this possible? The answer is reference frames. You are on the Earth, which means you are rotating with the Earth. However, the person in space isn't rotating with the Earth, which allows them to see that you're spinning. As you can see, different reference frames yields different answers. The reason why frames of reference are important is because sometimes our senses lie to us. For instance, when you are in a car driving at 100 km per hour on a highway, you would appear motionless if you just look at the other car. However, we know this isn't the case, and in reality, both cars are just driving at the same speed. Because our frame of reference was our own car, we falsely concluded that both cars were stationary. This makes it extremely important to always know your frame of reference. Normally, we represent frames of reference in two ways, inertial and non-inertial. In an inertial frame of reference, the object is either not moving or moving at constant velocity. If one of these rules is not true, then we are dealing with a non-inertial reference frame. In many cases, we use a coordinate system to represent frames of reference. We can then position objects in relation to their position from the origin. This allows us to track the motion of the object, both vertically or horizontally in a one-dimensional plane. Car sickness is actually caused by reference frames. You receive locational information from both your eyes and your ears, which can sometimes be conflicting. If we look at our legs or a book, our eyes tell us that we are not moving, but our ear hears the sounds of the wind going by and tells us that we are moving. This confuses our brain, which makes us sick.
Created using Powtoon.